Hey everybody, this is Larry. This is day 19 of April. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. It is just me doing an RNG palm. Let's see. Wow, we've been getting a little bit of streak of RNG hard lately. So I don't know what that means, but I mean, always up for a challenge, especially on Friday in the evening, I suppose. And there's no NBA game today, or candidates. Oh, there are NBA games today, but I just mean like no playoffs. I mean play in. I don't know. Either way, my point is let's take a look at today's farm. 272 closest binary search tree value 2. Given the root of a binary search tree, a target value, and an integer k, return the k values in the BST that are closest to the target. You may return the answer in any order. Target could be what is this? It's kind of weird. Why is target like whatever? Oh, if it's balanced, can you? I mean, no, because by definition, this O of k can be O of n, and therefore it cannot be true. I mean, you could probably solve it in terms of O of k. But I mean, I don't think this is hard. I don't know. I don't get why they have fractions. It just makes things like stupid, if you ask me. But and like we can have like I don't know. But in any case, I mean, I don't think this is that bad. It is kind of like it is tricky though. Because basically you what I want to do is this idea of like branching out, right? Like if you are able to draw a tree and you do a regular binary search operation of searching for the target, then now you're just basically going through like for example, if you want to get the next biggest number, then you just do an in order traversal from that spot, kind of, right? And and then to get the other side is almost like, well, now you want to get the it's not the, I mean, it's kind of like the opposite traversal going to the left, and you just have to kind of keep track of those things, right? How do I want to do it? I mean, I think there are good amount of ways to doing it. It's just about, I think the idea, the theory, the algorithm isn't that hard, but the implementation can be very annoying, if nothing else, right? And we can solve this in O of k times, well, O of log n times, or O of log n plus k, which probably is the lower bound. Well, I guess if it's not if it's not balanced, then I guess it can be O of n or O of h, where h is the height of the tree, just because that's how these things are. I don't know how because I guess it's not balanced if we have to assume it later on, but yeah, and basically you want to do like a two-pointer type thing, right? But in a very slick kind of way, because otherwise your memory usage will be terrible. Is just like two-pointer of like, okay, getting the next and then getting the previous, and some way of doing this, right? And I don't know that there's a easy way of doing it, or like it's not something that is asked very often in competitive. Maybe on interviews it has happened, I don't know, but on competitive you don't really do stuff on like binary search trees quite like this, right? Because you're not giving a data structure. But all right, let's practice this, right? So let's start with the very basic thing of doing a binary search, or not a binary. What do they call it? Like just a search on a binary tree, right? So okay, so we have root, right? So let's say and I want to do an implicit stack. Oh, sorry, not implicit. This is pretty explicit, right? But yeah, and then now I don't remember how to write this exactly, but it's fine, we can figure it out. So maybe while true for now, if no dot value is greater than target, so that means that we want to go to the left, right? So then now node is equal to node dot left, else node is equal to node dot right, right? There are some kind of things that have to be careful about, right? Because the value itself, like for example in here, 3 and 4, for example, is for 3.7. So it's not good enough that we get to 3, but maybe that's fine for now, right? Let's just return to do it for now, and then we can print node.value. Just kind of make sure that we're going in roughly the right place. Note that, oh, this is going to be none at some point. And this is just a while true loop, so that is terrible. But yeah, maybe just print node.value and while node is not none, something like this. Okay, so then now it goes 4, 2, 3, which is what we want. And I guess this is just. Is there no root? I don't get why it doesn't put any. Okay, well, so it prints 1, which is I guess what we want anyway. Okay, so we are able to get a node, and we don't know if it's the. So then now we want to get the next number and the previous number, and then in some combination we'll be able to get the first one. Right? Yeah. But here, why I want to do it with an explicit stack, I didn't do it that way, is that well, the short answer is so that we can manipulate it. And I almost want to do a crazy, because the thing is that it just, the way that this is structured makes it very hard to go up the stack easily, right? And I have to figure out the rules. It's just a very annoying problem, implementation wise, right? Again, now I guess we can write something like stack.append node, right? And then now we can maybe print the stack. And we should see 4, 2, 3. Yep. Well, I mean, yes, but I think it is printed very weirdly. 4, and then the 2 is here, and then the 3 is here. Okay, fine. Right. And then now, what do we do with this stack? Right. So the bottom of the stack is one possible result. So then now we have to get the next number, and yeah, maybe we have to do a get next thing, right? So stack, we'll just do the last that value so I can print it out just for reference, and then now maybe a get next, right? Of a given stack. And I'm gonna write this like very memory inefficient for now. I think what I want to focus on is getting it correct. There might be other ways that we can. I mean, we'll worry about efficiency right after we get it correct. So I'm very aware that the way I'm doing it is very space inefficient because I'm allocating stuff, and I already know a way around it, but I don't want to mess around with. Like, it's not the hard part of the problem yet, so I don't want to give ourselves two hard problems and just do one at a time. Right. Okay, so then now we have the stack, and then we want to get, so okay, so what happens? How do we get the next one, right? So, okay, so then now, top of the stack is you go to this thing, and then if okay, so then the parent I think that's why I wish there's like a parent thing. I think that's why this has been like very annoying to me. And I'm also tempted of like just creating parents as I have to stack, which I guess we can do really. But alright, fine. Let's do it that way then. Fine, because it just makes it like very weird. Right. And then here we can say, okay, well, we go down left. That means that parents sub node.left is equal to node. Here, parents.node.right is equal to node, right? So that's Gucci, right? So then now we can say, if top is in parents, print parents sub top dot value. I just want to. I know I'm like taking things very carefully, but I just want to play around with it and want to make sure that I get it right, because I don't want to debugging when you write the code when everything else it's almost like TDD, right? Like I know everything here is right-ish. Well, I mean, I guess this part is what we're testing, but so then now this we want to make sure that the other part is right. Output is 0, which is not. Oh no, output is 3. Actually, what I want to do is top dot value and then the parent, right? So 3, the parent is 2, so that's good. And actually, I guess that's the only thing that we have. We only ran it once, or the other thing doesn't. I guess this is just false, but that's because the one here is the root, right? So the root doesn't have a parent, which is true. Okay. So what does this do for us, right? That means that now we can say, so if else, then we're at the root, I believe, unless we mess something up in the traversal, right? So then now root is the parent, and so that means that there's no get next, right? So then now we can return maybe. Oh, root is not the parent, but the top of the this node is the top of the stack, no parents. Or this node is the root rather. Whoops. So maybe we can also even assert top is equal to root just for funds. And then here, that means that we can get to the parent, right? So parent is equal to top of parents top, and then now we can check if parent.left is equal to top. What does that mean? That means that we can go to the right, right? So then now we stack that pop. Well, the next value is actually parent, right? So then now we stack that pop, because then now I'm looking at here so that you can think about it. If we're at the node 1, then popping it, we want the next number is 2, right? So we get to the 2, which is true. Yeah, okay, yeah. I think the thing that I'm trying to think through is how do you differentiate the next node being the right node versus the current node? And I think is that when we do the push, we'll see, right? Okay, so the parent's top is we pop, right? And then that's it, because then now we return the top of the stack, which is the parent. This should be the parent anyway. So this is the parent node, and the parent node is the next node, right? So then now what if, okay, so what if parent.right is equal to top, right? That means that this is the right node, and then the next node is going to be, so I'm looking at this again, and this is the scenario where we're at 3. But we're trying to go to 4. Maybe. There is one more scenario, which is why I'm trying to think through how this even works. Because basically, because I'm missing the scenario where, oh no, I guess this part does it for us actually. But then now this gets 4. But then after 4, how do you get to 5? Right? like here, what we want to do is return 4. I mean, this is not real code. But then now, what if you call it again on top of the stack? Then you want to go to the next node, but that's not possible, is it? Or like, I mean, it may be that I just need to add another enum or something like this, but it's definitely awkward. And I would also say that I think I missed saying, oh, I did forget to say it, but n is 10 to the 4th, so you can also just like do a regular thing and then sort. It'll be n log, or like with a heap, you could do an n log k type thing, but I don't know. I'm trying to do it in a O of n plus k, O of log n plus k, or whatever it is. Okay, I think I get it, but I think I think I get the scenario. I have to double check it, but all right. So then parents dot right is top. Then now we want to keep on popping until the next node that has a right child. Is that true? I believe that's true, right? So then, okay. Well, we have to pop the current item anyway. And then now, while, I don't know. I think this should never be the case. Like, that is not true. But let's just say right is none, then we keep popping. And then now the top of the stack should have a right node. Or if not, then we're just done, right? So then here, maybe we want to say if length of stack is equal to 0, we just return none. We're done. Else we just return the top of the stack, and that should be good. Yeah, that's for consistency's sake. I want to write the top of the stack. And here you can kind of see that we are these do the same thing, so we can probably generalize it by taking it out. But okay, so then the question is, I think there is one more scenario, which is that the current thing. So before we pop this, we want to say, okay, if, oops, not here. If top dot right is not none, then we visit the right side, right? So then we stack dot append top dot right, and then we can return the top of the stack again. And maybe make this else if, and then you can also like take this out again, but I don't want to. It's fine. I think this is maybe don't even have to be else if, just for consistency. It's a little bit cleaner, not that much, right? And the reason is just that, okay, now you have this. Oh, but that's not enough, is it? Okay, if it's not none, then you do this, but then now you have to go all the way to the left, which gives us that condition, which is that while, okay, so then now we say current is equal to top dot right, maybe something like this, while current is not none. I'm reinventing that for search, and this is terrible because I have to do get previous and reverse a lot of this logic, which is gonna be, I mean, probably the same, but also very easy to make a mistake, right? So stack dot current, and then current is equal to current dot Okay, so we went to the current dot left. Okay. Yeah. All right. I think this is okay. Let's run the code real quick. This doesn't do. I didn't print anything. What does this do? So we return to a node, right? So we can print this, right? So then now we can maybe, yeah, return. I don't know. What is this? The top of the stack, and then after we run one level of get next, yeah. And we can even maybe write something just like current is equal to the top of the stack, right? That's the node that we care about. And then while next node is while is this is not none, then yeah, then we print next node dot value, right? Something like that. If it infinite loops, that means that we're bad anyway, and we might do it. The only thing that I added is here, and that cannot be an infinite loop, so I don't know. All right. I mean, I don't know why it takes so long to time out, but okay, fine. What is going on here? Did I print out too much? Too little? What to tell? But can we tell a little bit earlier? I think server is just having issues. There's no way that timeout. It's been like longer than 10 seconds or whatever it is, right? Time limit exceeded, but taking forever. Okay, fine. I guess it just takes so long. Oh, maybe because it takes a while for us to download this. Okay, maybe not, or whatever. I don't know. What is the 3 and the 2? 3 and then the next is, wait, what? All right, let's just run this real quick. But clearly there's some infinite loop, and maybe I want to get rid of this case. So we now only have one case, and then it should, the output should be, why do I have 3 outputs? Do I have another print? Oh, I do have another print. All right, so 3, the next node for 3 is 2, which is wrong, right? So we have to double check. It should be 4, so, okay, so, oh, because I don't update the parents, that's why, because I meant to, when we push stuff to the stack, we have to update the parent. Yeah. Yeah, this could give me none, right? So that's a little bit awkward. I guess this could also give me none, right? No, that's fine, whatever, YOLO. Still 3, 2, huh? Wait, what did I change? Oh, I added the parent stuff. That's wild. All right, let's trace this a little bit. Right, to the top of the stack is going to be the 3. It does not have a right. Oh no, yeah, so that is not true. So then top to parents. Now it is going to be the right node, so we pop the 3, right? And then now the stack. Oh. I see, because now it goes to 2, but then this is never going to happen because stack.right is well, it's going to be top. This is top, that's why. So we need to pop 2 times because the parent is definitely done because that's what because we don't have parents. Okay, so then now we get it right. That's a very tricky thing to catch, actually. Maybe not, I don't know. But then now here maybe we can try this again and hopefully not get a TLE. I mean, I don't even care about the thing. It's just that it takes forever. Okay, fine. I was too optimistic. Let's run it again, and then hopefully this gives us 5. Hopefully this gives us less than 10 minutes. I'm gonna get some water. Alright, 3, 4, so it's gonna give us 4 the way. Alright. That's the part where, oops. But this is true. So what happened? So 4 is the top of the stack. Alright, we went 2 loops. Let me recheck it. Okay. So 4 is the top of the stack. Let's print this real quick. Print the stack. You need to use the restroom, to be honest, but alright. We'll stick it up for now or whatever. I don't know if that's a real term. Okay. So 4 is the top of the stack, which is what we want. This is true though, right? So parents of top to the right is gonna be top. Okay, current is top to the right. So then this doesn't do anything. Is that true? Top to the right. Yeah, I guess we don't do anything. Why? Top of the stack. Am I right? Am I reading this right? It's always hard to tell with these. Left, right is 5. Oh, I'm dumb. It's because I make a copy here. So that's why I kept on doing it. Okay. I need to make a copy, but maybe not there, I guess. Okay. Okay. There we go. Current is none. So, well, current is not none, right? Oh, I have to do it before. Whoops. Okay. So now we're good because we do it correctly with the reference. And we have to be careful because the reason why I did it this way is because, I guess, yeah, I didn't need to reallocate here. So, okay, fine. I'll just do it this way. But we have to do it here. That's why. Okay. Okay, now let's see if this, I mean, I think this now gives it to us, maybe, hopefully. The thing that I missed is that, yeah. Okay, but let's just call it stack right, as in, you know, to the right, right? No, I guess I should print. It's a little bit messy, but it's fine. 3, 4, 5. I'm just debating whether I want to create a bigger case to be more visual, right? But we can also just do this to like 1, and then it should give us 1, 2, 3, 4, 5 if we're correct. And it does. So we're pretty good here, right? It's a lot of code. It's really messy code, and a lot of the logic I didn't really explain, to be honest. But it's just going through the stack and going up the tree. I mean, I just kind of went through the cases, right? I don't know that I did anything crazy. Right? And then now we can do get previous, which is the same, but the other side. And now we have to kind of go through it, right? I mean, I wouldn't say I'm 100% confident about this right now, but it is pretty okay. Can we add more things? I guess, but I don't know. I'm lazy. It's yeah. If we get it wrong, we'll debug it. I don't know, right? And then now we do a get previous, because now we basically have to in order, and now we have to go backwards, right? So it's probably going to be very similar, but then now we have to think about the situations again. I don't know that I can just do a symmetry thing. Maybe I can. That's YOLO a little bit about it, and just do a symmetry assumption. And then just by, you know, doing this, right? And basically just swap everything left to the right so that we go on the other side, which should be okay. Maybe not, I don't know, because I'm too tired to think, right? All right, so then now we could do this, right? And then now we can try again, but now with the left, right? Let's just say right, left, right, and record stack left. This is get previous. Right and left. Okay, that looks good. Did I have a whoops? I mean, that should not return anything anyway. Maybe it gives me an infinite loop though. If someone goes very terribly wrong, it just might just be wrong anyway. Because there's no reason why it should be infinite looping. I don't know why it is infinitely looping. Okay, well, so one, it tries to go to the left and it goes to find a 4. So that is just very wrong. Where it should give me a none. So okay, so why is that? So we're at 1. Yeah, we're at 1, right? And then here, if the left is not none, okay, I mean that's fine. I think we're good here. Left is none, so then yeah, we go up to parents. We go okay, it is the left, so then now we pop, and then we find the next one where left is right. So it finds 4. So I think this logic is a little bit wrong. Why is it not symmetric? Am I doing something wrong? Like there is some underlying thing with some symmetry, which is why I kind of just copy and paste it, but I mean 4, I can see why it gives me a 4, but I don't know how it stops. And then 4 and then previous is 3, 2, 1. I mean, that's great, but how does this handle it if it's 5? 5 is that, okay, let's say it's 5. Top is in parents and is on right, and then we pop. Oh, so this isn't right on the get next. It's just that we don't have another thing, right? Because let's say we have, I don't know, if that's 6, this will equivalently be wrong, I think, right? So we can add, how do I add a 6 here? Oh, tree visualizer, okay. 5, 2, 5, 1, 3. Does that work? No, I mean, how do I? Does it have to be complete? I don't get it. Like, how do I insert a none? Because none just gives me an error, right? No. I guess. What? I don't. Okay, fine. Okay. So I think if I do it this way, it would also give me an output limited, except for. Okay, so that's definitely wrong. It's just that I got very lucky with. I don't know, right? Okay, so what does this mean? What we want to do, well, let's look at this one. What we want to do is, maybe the pop was always a little bit weird. What we want is that, okay, so I was thinking about if we're 3, we go up, right? And then we want to find the next number that has a right node. Yeah, okay. I mean, that seems reasonable. But let's say you have 6, right? And yeah, you could see that this 6 doesn't get out. Right, so let's say we have 6. we pop, but now we have a right, which is not quite what we want. So okay, so we keep on. We have to, so because we're on the right subtree. So while this is okay, fine, I see it. Okay, so then now, so we definitely want to go up, right? So then here maybe something like, while parent dot right is equal to top, we pop. Okay, so this pops to item, and then this is actually, I guess technically, how do I write this? Maybe I guess I could write it here actually, like this, right? And then now top is equal to stack, right? And parent is equal to, what's it called? Parents up top, and then this keeps going. And then now after we pop off all the right subtree, then now we're on a branch that's going up left, then we do this other thing, I think. Okay, that is okay, fine. Right, I think I generalized a little bit poorly before, right? Maybe I could have, I don't know. I mean, this is taking too long. I need to write code that's a little bit easier to debug. I mean, it's easier to debug, I don't know. In most other things, this gives you the live things, and then it just kind of, you know, like I don't need to wait the entire output to output limited exceeded, but it is what it is. Okay, so 1, 2, 3, and then now it gets stuck at 2. Why? Did I miss a pop? So while parents dot right is equal to top, we pop. Right, so then now we pop the 3, now we're at 2. 2 is on the left branch. Okay. So then, oh, I think we have to pop one more time because this node is the previous node's, I want it. Huh, what's happening here? Well, 1, 2, 3, 4, 5, 6 is right, but it seems like this is failing because I'm not writing enough. Where are my pushes? I think this is my only push, right? So only traversal. So what am I missing? How am I missing something? Oh, it's on this one, but still shouldn't be. We only traverse here, parent current level 0 current, and here. Oops. Oh, 4 is the root, so of course 4 has none. Okay, I see. Yeah, maybe we just have to do something like parents of root is 0 none. Maybe that's fine, and it gives us none. None have where they have this as a highlight. Do I have to click on it or something? All right, 40. Okay, so then now this gives me none, so which is true. Now we're at the root. Annoying, but fine. So that means that this probably failed, so that's a little bit awkward, maybe. What is it printing for me? So it's still on the right side. So then it goes to 6, and then now it pops everything, which is true. But that's fine. Okay, fine. Well, parent is not none, maybe. Okay, and then we have to do it on the other side. This is why you don't copy and paste when you can, but the way we came up with this is a little bit awkward, as you know. All right, so you can tell now we're Gucci. right? That's actually all. Let's also put in the other ones just for fun. So then now you can see that's 3, 4, 5, 3, 2, 1. Cool, we're missing some stuff here, but that's fine. We can take a look. Oh, well, I guess we'll take a look now. But what is that? 41. We just have to add more checks. I think this is because this is the root node, and root node we don't really handle that well. Oh, because this is none. That's why. Because the original way that we had it is that we returned this thing, but this never happens anymore because we did this thing. The root node is always so awkward. Okay, this node is the root node parent. Okay, fine. Let's remove that, and then yeah, and then now this is gonna give me none, right? If parent is none, then we return none. Maybe that's good enough. All right, so then now you can see is 1, 1. Okay, fine, right? Whew. Right, I know. I mean, now we have all the answers we need, right? Oops. Took us a while to get here. We're about 41 minutes in, and I know that, you know, on a contest maybe I'll go a little bit faster, but I don't know, maybe not that much faster, but yeah. Okay, so then now we have an answer array, right? And now we can get rid of, well, let's just comment it out in case we need the template, but, and also for debugging later. Okay, right, so then now because it's not clear that the current value is the whatever, right, is the smallest, right? The smallest can actually be the left or the right. Okay, so then now, which is a very annoying kickoff, to be honest, but how do I want to handle it? I'm just trying to think. I mean, like, we could hack it out, but yeah, I think we need this anyway in any case. And then now we can say right, K. Yeah, 4 is the actually closer number here, right? So it's a little bit awkward, but we have target. Let's just say left value is equal to get next of stack left. Right value is equal to get, oh, this should be get previous. Get next of stack right, right. I mean, this is actually easy, right? But it's just that now we have to take a count current, which is technically not in left or right. I guess maybe that's fine, actually. I guess we can just say left value is equal to current. Now, it's a little bit awkward because, for example, here, in this case, for 3.7, you're gonna get 3 and a 3. But if you take it on one side, you'll get a 2 and a, like if you get to choose between 2 and a 3, but the next answer is actually 4, right? It's a little bit awkward. But maybe that's fine. Maybe we just do it the sloppy way of answer dot append. What was it? Current dot value. Current is equal to stack, the top of the stack dot value, right? And then now we append current. We append left value. We append right value, right? That's not right, because you may go to the left like many times before you go to the right. In fact, you may never even use current if you but we can hack around it. It's just so annoying the way I mean, there are a lot of edge cases and we can handle all of them, but it's just annoying to handle them cleanly. That's fine though. We could just say like for k plus 2 or something like this, and that would give us maybe plus 3, I don't even know. And then we'll just take the top k, right? It's a little bit sloppy, but I really don't like it, to be honest. Let's just do some if statements, right? So, okay. It's okay. If let's just do it this way. I'm being lazy. Okay, right? And then while left value is none, while right value is not none, then we append right value, and also right value is equal to get next stack right. Yeah, okay. And then the same thing, but for the other side. This is just like merge sort type thing. And then now, otherwise, we just take, all right, so then while, or if, this shouldn't be a while though. Or this shouldn't be a while because of this thing. So then, okay, so maybe it should be if sorry, I'm just like so out of sorts. I mean, this problem is actually kind of just annoying. Reasonably. All right. So then now, if left value minus target, right? If this is greater than right value minus target, then we want right value. So then right value is going to get next of stack right. Before that, we append right value, right? And then else we append left value, and left value you get previous of stack left. I don't know about indenting, but what are you doing? All right, I guess continue just for consistency though. I think that's done, right? And then though, yeah, they could both be none because of the way that we set up the k plus 3. So here with left value is none and right value is none, then we break. And this should give us most of the answer. It's not quite right because of the weird way that we handle the edge cases, but let's give it a spin real quick. What? Oh, is which one is the? Oh, we returned the node. Okay. Where? It's a little bit awkward now that I think about it though. Oh yeah, then this can be none. Alright, fine. That's why I didn't do it that way. But it is a little bit awkward. I mean, we have to do other things, that's all. It's not that big of a deal. Which is that now we know that it's not a thing. Then we can do, right? Which is fine. But then now we have to, on the pen, we want only the value. Okay, fine. A little bit more consistent. I'm passing out. This is very tiring. Okay. What are we talking about? Serializing. Oh. That means that we're appending. Oh, yeah, okay. I hate you. I actually knew this, but I don't know. Not a smart man. The reason why the duplicates are not great actually. Why are we having duplicates? Oh, because no, this should get right. Why are we duplicates? Everything else is fine. Like we knew that we're gonna get extra something, but also what the? I thought we were gonna get a little bit extra. Oh, because this 3. Oh, then we don't need this 3. Whoops, I did it. I don't know what I'm thinking. Okay, I mean, so it's not by that much, but then now why do we have dupes? And 3, and this is 3, this is 2, this is 4. So we have 3 to 4. But then why? Continue. Huh? That is a little bit awkward, actually. We'll see if this prints out anything good, and the answer is no. Alright, so it's 2, 4, but we already added, let's see, what? 3, 2, 4, yep, and then now the 2 and the 4, but why? We already, oh, we did this here. Okay, fine, I guess we don't need this. Maybe, we'll just be a little bit wrong, and then here we'll do 2 extra loops, and then now we don't have any dupes, I think. Okay. The reason why we do it this way so that then now we can remove some numbers. What is that? Why am I? Okay, plus 2. I guess that's fine. I guess that's right. Actually, it's not great, but it's right. So the reason is because we assumed we added 1 extra number because we assumed that current may be thing. I chose 2 just because it's easier to do, but I guess maybe even k should be fine. Then now we have to now we have an extra number and we can remove it, and that's what I wanted to do. Yeah, so which is that. Okay, so then now while length of answer is greater than k, right? And now we have to remove an answer. This is, in the worst case, this could be linear, but I mean, this should only filter once. to be honest. So yeah, so then now we get the max number, which is x minus target, right? So max of absolute for x in answer, right? Does that work? I have to do this. Oh no, I'm going to infinite loop because I forgot to do it. All right, and then now answer that. Yeah, that's silly. Okay, fine. Yeah. For I in range of length of answer, right? If I'm X, then we can remove this thing. So we just do. How do I remove just one item? Someone tells me there's an easy way to do it, but I think whatever. Oops. Someone like this maybe, right? That looks good. This should only loop once, even though yeah, it looks awkward. We can maybe assert. And let's give it submit. Am I confident? Maybe 80%. I mean, okay. That part is crazy, actually. How can this happen? What is K? Actually, I didn't. That part I didn't expect, to be honest. Because this is just. Oh! I'm dumb. I actually needed a brick. Literally. Okay, fine. I meant to do that when I did it, but I forgot. Okay, wrong answer is a different thing, which is fine. Yeah. I know because of pigeonhole, it shouldn't be, but unless there's another thing. So I'm missing a 2, which is true. That rhymes a little bit, which is okay, fine. And I have 45, 46, 47, so that's not right. But what? Why am I missing a 2? Is 2 on the tree? This UI is so bad to read. Okay. Okay, 2 is here. Alright, that's so this is gonna be left, so let's print out the left real quick. Okay, so 54310. Huh. So that's wrong. We have a wrong answer. This is the tree. Right, 5, 4, 3. Oh. On the previous, I thought that we want to keep going up. Okay, I mean this is legit. I thought that we want to keep going up on here, or maybe the other one. But it's a little bit off. If stack.left is none, then we pop. Is that true? No, maybe not. Okay. Yeah, I think I messed that up. I don't. It was basically now because before I was skipping that element. Okay, which is true because I was skipping that element. I don't know why I thought that. Well, I thought that would be processed, but clearly not on that route. All right, let's give it a submit. Oh, I mean, only one minor logical error on this is not that bad, if you ask me. Well, I mean, the second one, this one, what was that one again? Oh, I just forgot to break. I mean, I knew that this would, because the reason why this goes out of bounds is because we changed the iteration or whatever, the array, so then it goes out of bounds because the array size changed, and I forgot to break. That's a silly mistake. The wrong answer was a legitimate one in logical error. I guess I didn't really trace that through. But yeah, I mean, we got it right. And yeah, this is going to be O of, this is very messy, but O of n time, O of k space, whatever, it's very minimal. Let's take a look at the solution. Sort, I mean, yeah, obviously you can search everything and compare. That would be easy. Traverse with heap, we already mentioned. In order, traversal and sliding window. Huh. Binary. Oh, this is good too. Maybe that would have been easier. Build the window of deck. Apparently, we did it in a funky way that is not any of the way that they mentioned, but the Windows idea is pretty interesting actually. Oh well, then let's go over this because it's not the ones that they talked about. The get next really only takes O of h space, which is the height of the tree, and of course, I guess in the worst case, this is O of n. This is O of n time, but every core of this, we only look at each node once, right? This is basically a deconstruction of the depth first search, or in order traversal, to be more clear, to be more specific. So every node gets visited once. So this is linear time, linear space, and yeah, and we don't even. And the reason why I kind of did this funky way so that we don't have to sort. This is basically like a 2 pointers branching out. So you look at each node once, as I said. So this is going to be linear time. The only reason why I use pigeonhole to make sure that we added one extra number, so that means that one of the numbers is going to be incorrect, and so this is why we have this weird while loop. But because we only do this once, you know, this is basically a linear thing, so everything is linear time, linear space. That's what I have for this one. Let me show you the code real quick. This is the top, this is the traversal to find the node, this is the get next, which is basically given the core stack or the DFS stack, it tries to get the next item, and here same thing except it gets the previous item. And here is the here's just some setup. Here's the 2 pointers expanding outwards, and here's the replacing the extra one, because there is this like very tricky case where the node that you found may actually never be used, right? For example, if you have this thing, right, and you have like 4.2, maybe that's not a great example, but let's say we have this tree and the 5 is like a million instead of 5, and you have 4.5. It's possible that our binary search tree will just give you, maybe we could be a little bit smarter about it, but the way that we set it up, it can give you the million, right? And you never use the million because all the small numbers are all the way to the left, but that's how we roll it. So that's why we kind of use this pigeonhole idea to just eliminate one of the max. And yeah, very tricky, very full of edge cases. I mean, it's not that, I don't think that it's that hard conceptually. Maybe if I did some of the other solutions, it would be easier to implement. I just thought that the way that I did this problem is very difficult implementation-wise. But and yeah, during the contest, I definitely maybe would have YOLO this because I think this is pretty straightforward. If I want to be a little bit less straightforward, I would use the heap version of it. But that's, you know, yeah, pretty straightforward in general. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.